Okay, it is time once again for Odinmade Hero, the programming series where I follow Casey Muratori's Handmade Hero in C and C++ in the Odin programming language. Now, where we left off on Wednesday was kind of a bummer, but it turned out to not be a big deal, which I am grateful for. I can figure out where my editor is. So it took me a while to figure it out. Just looking at the problem, it seemed to me like it was a rounding error in the world code, right, with this math.round call right here. And so I was thinking that the problem I was seeing was exactly what this to-do describes, as I mentioned probably like 3 or 4 times during that stream. Need to do something that doesn't use the divide and multiply method. Mighty, do you have to shake the whole house when you scratch yourself? Doesn't use the divide multiply method for recanonicalizing because this can end up rounding back onto the tile we just came from. And so I thought we were basically rounding back and forth between Z tiles, essentially, up and down, because now we've got this notion of 3D traveling through, you know, the Z plane in 3D space, even though it's a 2D game. I thought that was the issue, but it turned out that I was just passing in these parameters to the lineage package's lerp call out of order. And it's weird because I'm pretty sure I was looking at this call's signature and thinking to myself, well, I looked at it because Casey defined it basically as the T right before the B, like this. So, or ordering these parameters, the way he defined the signature, it's in this order where the T is before the B. But the lineage package orders it like that, and somehow, even though I looked at that and I think I called it out loud at the time, I still passed them in wrong. And that's because I immediately got kind of distracted and a little bit confused about what it is we're even passing in here, because we got this barycentric thing going on, and then we have the region rectangle. But this makes sense, right? We're going from the min Z to the max Z of the region rectangle that we care about, which is the bounds of the test entity going out in its dimensions from its origin, right? And then we have that barycentric y coordinate coming back from this call. So I goofed, you know? And so it was a well-deserved bit of flogging that I had to give myself for messing that up. But now, when we build and run, we're exactly where we need to be to start off day 76, which is that we kind of have this notion of a staircase. You know, there's no staircase being drawn here, right? But, and there were a couple other things going on, to be fair. There were like random typos that I had left in the code from, you know, just being too hasty and making changes in days prior, but everything's looking good now. So we can't enter the staircase from the back of it or from the sides, but if we go up like this, you know, from the bottom, then we can actually go into that second story. And so now you can see we're in the second story, and the first room where we started is down there. You know, the 3D perspective is kind of working a little bit more interestingly now as far as the way it's presented to us, because of that Z-fudge thing that Casey added at the end of the last stream. So we're looking good. Now we're not getting that glitchy craziness going on, but we have some weird issues with, like, you can see the shadow of the player is not properly following the hero as he goes up and down. But other than that, it does feel pretty nice to work with, you know, just kind of skate up and down between the rooms. That's a pretty neat little transition that we get. So we'll keep moving on with day 76, where excuse me, where we'll deal with entity heights and more collision detection. So just kind of continuing to solidify this stuff that we've been working on for the past week or two. Eric the Outcast, hey, how's it going? Eric the Outcast said, I will join for the lurks, have fun with all the coding. Sure, I appreciate it. Enjoy your lurking. Okay, so let me bring this over here, and we'll let Casey kick it off.
Back to Handmade Hero. We have been on break for a week, but it is now time to get back to coding a complete game from scratch, live here on Twitch. And we stopped before break at a point that was kind of somewhat interesting, actually. We were starting to do the work that we needed to do to make sure that we handled three-dimensional stuff correctly in our engine all the time. So we're a 2D game, meaning we're supposed to be a game that's similar to Binding of Isaac or Legend of Zelda, these sorts of games where you kind of walk around, and it's very much supposed to be a 2D experience, or something, I guess, like Don't Starve. But we actually are trying to allow sort of full 3D stuff in the world in so much as we care to have it, so we want to make sure that there's nothing inherent in the way that we've made the engine work that would cause sort of jankiness to happen when you want to actually do stuff like multiple levels on top of each other or things like that. And we'd also like to be able to do stuff like have multi-level rooms where you can see perhaps the room below where you're standing, in the case where there's a hole sort of in the floor down to where that is, that sort of stuff. So we want to make sure all that stuff is handled cleanly and not really in a hacky way. A lot of times there's kind of hacky ways to do it where there's exactly two levels that there can be or something like this, and or it's kind of just a hack in the way that the graphics are drawn, but it's not really handling it 3D. We're trying to do it a little bit more robust than that so we can do more interesting stuff if we so choose. Anyway, that's what we're working on right now, so I'm going to go ahead and get back into it because I think we're going to need some time today to just kind of get warmed up again. It's been a full week since we last programmed. It's been more, actually, because it's been 2 weekends in between, so it's been more like 9 days or something since we programmed. So what I'd like to do is jump right back into it. Again, if you already pre-ordered the game on handmadehero.org, you can download the source code, so if you want to follow along with today's stream is stream 76. At least I think I set that correctly. Let's double check and make sure that I haven't lost count. Yeah, 75 was the last one. So what you want to do is you want to unpack day 75's source code from the source code zip file that comes with the pre-order. You want to unzip to day 75 so that you'll be at the right place today if you're trying to follow along with me at home, because I will be starting with day 75's source code for this episode. All right, we can kind of put mischief down minimize that into the background for a second here. And I've restarted this computer since then, so hopefully everything is still working properly. I guess I don't know that it is. I guess let's just open up our programs and actually make sure that nothing has gone terribly wrong since we have left things. You never know. You restart Windows and anything can happen, ladies and gentlemen. You really don't know what you're going to get when you restart a Windows machine. Really, anything's possible.
You don't even need to restart Windows, and some crazy stuff can happen. It doesn't matter. Any time. There's no time that's off limits for Windows to do weird stuff.
So it looks like things are roughly the same as when we left them. That's a good sign. And our stairwell looks like it's working as well, so that's good. So it looks like nothing particularly bad happened. We're still able to run okay. Everything looks good. And so if I remember correctly, what we wanted to do, what we had been planning to do at the end of this, was first of all, we wanted to maybe do a little bit of cleanup on how we were doing our collision detection for the stairwell, just kind of clean up some stuff. We'd only just finished getting it working kind of the way that we had wanted it to work. And the other thing that we'd wanted to do is get our collision detection properly working with heights of things, so that if entities are brought into the simulation set, like in this case we've got sort of two playfields going here. We've got like a lower one and a higher one. You can kind of see these two rings of trees. That's sort of the downstairs, and this is the upstairs one that we kind of had put in there. If you've got situations where you've got multiple entities in the working set like this, and some of them are below you, right now we're just doing that collision detection in 2D, and that's not going to work because it means that we can't ever get through what should be an opening here, because we're going to collide with the trees on the bottom level as if they were trees that we would have to worry about on the top level. And so we need to make sure that we're actually taking into account where things are in 3 dimensions when we process collisions with them. So that's something that currently we do for inclusion testing. For example, when you're working with the stairwell, we are actually testing where you are in 3 dimensions there. But when we're testing against movement, like to see whether you can pass through something, to see if you've collided with something in that movement step, we're not actually using the height of things at all there to see whether or not you should collide. So that's another thing we got to do. Finally, the big feature that we need to work on, and that's hacked in there in a minute, at the moment, and that we'll have to sort of do possibly at the end of this stream, and probably tomorrow will be most of what we do, is we need to start coming up with a definition for what it means to have a particular ground height. Right now, we're sort of just doing a really cheesy thing where we just assume that the ground height is wherever the camera is. So when the camera moves up and down, we set the ground height to be wherever its sort of camera center point is. And that's not really going to necessarily work. I suppose we could decide to do something like that as the permanent solution, but it seems to me like, kind of a little janky, and it would also fight our ability to move the camera independently of where the ground is. It also makes it harder for us to define things that say where there isn't ground or stuff like this. I don't know. There's just, I haven't thought it through too much, and we need to go think it through so we can kind of define exactly how all that stuff's going to work, so we can get a nice stable way of understanding where the ground is. So right now, that's totally hacked, if I remember correctly. So that's what we've got, and that's pretty much we've got our work cut out for us there to get all that stuff going. So let's go ahead and start working on that. The first thing I think I'm going to tackle, because it's the easiest one to do, it's very straightforward, is just to get our collision detection working so that things are only colliding with you if they're in the same sort of Z neighborhood as you are. So if something's above or below you, that it won't collide. So what I'd like to do is I'd like to go ahead and go in here to our handmade sim region. And when we do our move entity call, right, this is where that was happening. When we did our move entity call, we had this iteration loop where we would go through and we would try to move the entity, and we would do a check against other entities to see whether any of them were hit, right? And since we haven't really done general collision detection yet, we only did it just for little square things. We still have this call is still called test wall, and basically all it does is it just tests against a single basically line segment that is you know, on one of the axes, like X or Y or something like that, right? And if you'll notice, Z is not taken into account there at all, right? There's absolutely no Z included here whatsoever. And now what we could do is go expand the test wall function to actually handle Z, but it's unclear why, you know, that's not really probably a good idea, because when we do the final collision detector, we're not going to use test wall, and the things are not going to be rectilinear, and they're not going to be axis aligned, and so really there's no point in updating the test wall call. The test wall call is probably fine for our purposes. What we'd rather do is just say, at the outset maybe, let's just say we're going to look to see whether these two entities overlap in Z, and if they don't overlap in Z, we're not going to do any testing on them. So basically we'll just, in here, right, when we're actually doing this, we'll just full on say, when we look at the can collide, the first thing that we do after we do you know, the testing, maybe we'll still leave that Minkowski diameter and the min-max corner thing in there, but right after we do that, we'll do some check to see whether the entities overlap in Z, and if they don't overlap in Z, then we simply aren't going to test them at all. Now, we've already constructed stuff that will help us test whether things are in Z. We've got this Minkowski diameter here, and the Minkowski diameter is the size of the entities added together. So basically, we've got the size of the entity in Z, we've got both of those sort of concatenated together, which means that we then use that to compute the min and max corner, which is basically the value of, excuse me, if you assumed that the entity itself that we're testing against, the colliding entity, if you will. You know, I'm saying too many things here. I should probably just draw this out. That's probably the easiest way to explain what's already going on in the code, rather than me constantly trying to say stuff there. So let's go ahead and thank you Windows for that wonderful, helpful. There we go. What I want to do is I'm gonna you know, go ahead and find a place here where we can make a new thing. There we go. So we'll say day 76. And what I was trying to say before is we have two entities, right? Before we had basically, like, you know, the wall entity, or the entity we're testing against, which doesn't necessarily have to be a wall, but that's the most of the things that impede our progress at the moment. And we had the hero, right? And each of these had a dimension. So it had a measurement that said how wide or how high or anything it was, right? And so if you imagine we had the hero's dimension here, and we had the wall's dimension here, so HD and WD, let's say, then what we decided to do, because if you remember the discussion of how Minkowski algebra works and stuff like that, what we wanted to do is just treat the hero as a point that moves along lines. And in order to do that, we need to shrink the hero down to a point and expand the things against which he is colliding against by his size, right? So what we did is we said, all right, let's expand the wall by however big the hero actually is, half on this side, half on that side, right? Expand that out and treat the new size of the wall to be the size of the hero plus the wall, which effectively shrinks the hero down to a point for testing, right? And then we said, well, we'll do this relative to the wall, right? And so the way that we did that was we said, let's subtract that hero location, right? If this is the point that the hero is at, let's subtract that from wherever the wall is, and we'll just get a relative point. So what that means is now, if we wanted to do Z, if you imagine a side view here, what we've already done is we've already constructed something where we basically have the hero's point, right? We've got that relative to here, and then we've got a min and a max Z, right? We've got a max Z level and a min Z level that already tell us sort of whether if we took PZ, right, it would just be this. It would just be where we are on the z-axis. We can just see whether that's in between that min or the and max, right? And that will tell us whether we can hit this entity or not. If we're outside of those bounds, there's no way we're going to overlap with it, so we want to just ignore it at that point. So really all we have to do here, very straightforward, we can just take that rel. We can take that rel z, and we can say if the relative z is greater than or equal to whatever our min corner z is, and the rel z is less than or equal to whatever our max corner z is. Now, and again, this is a little iffy here because we don't really have, you know, I'm gonna put it to do here when we finally do the full collision detection. Do we want an open inclusion at the max corner? Because you notice I'm doing less than or equal to in both cases. There may be, you know, if you remember when we did our rectangle code, and maybe I'll just do this because it seems like it's a little more consistent. But if you remember when we did it here, we were saying that the max typically is not included. So it may be a little more correct here to just say that for now. I don't know. We don't have a robust definition. We don't know why we might care. And so I'm going to put that off till when we do the collision detection full pass, because at this point I really just don't know, if that makes sense. I really just don't know what it is that we would want to do there. We'll have to think about it. All right, so if I do that and I do that test, now we should have, and again, I'm not totally sure, but I believe we should pass through things that are not on our level and stop on ones that aren't. Okay, that looks like we're just passing through everything, which is not what we want to do at all.
It's always fun. It's like, hey, this is what we're trying to do. Let's see if it actually worked. And then you go to try it, and it blows up in your face. We'll see if we get the same result on my end. Well, I was able to just, like, walk. Yeah, okay. Well, I guess that's fine. So yeah, we can pass through all of the walls now. Walls mean nothing to us. Really, this was just a power-up that we got. We are now, what's the Rogue? Is it Rogue from X-Men who can just phase through walls and stuff? I forget what that power is called. but there you go.
Oh, it's always funny. So I wonder why I got to see here what I'm doing.
Rectum of Justice, great name, by the way. Said, I found you through your YouTube stream archive. Have been watching the VODs. Oh, having the VODs on in the background while working. Nice. I'm glad you're getting some use out of them. It's been, as I say it every time now, it's a very strange journey, and I don't know where it's going. It's been pretty interesting for me. It's been making me think about things that I either haven't thought about at all before or haven't thought about in a long time, and it's been motivating me to get more creative in other ways too. And that's all I'll say about that for now. But it's been awesome, and I'm glad that other people are seeing what I'm doing here and finding it interesting on some level too. Because there'd be no point otherwise, right, of streaming it at all. So, yeah.
Oddly here, I'll set a breakpoint there and we'll see. But I believe, am I doing anything obviously stupid before I test that? If rel z is greater than or equal to min corner z and rel z, no, that looks basically right. So I'm gonna step in there and see what's going on. Again, it's been a while since we programmed, so the chances of me forgetting something about how our code is working is pretty high, but what are you gonna do? All right, so let's go ahead and step in here. We should, what's going on? There we go. We should be able to do some, oops, let's see here. I guess we should be able to step in at any time, and we should be able to see these triggering, right? So let's see. What is our min corner and our max corner that we're testing against here? Let's just find out what those are. So let's see, min corner, and
I suppose if I had to guess, the walls might not have any Z to them, just very superficially. I don't know how long it's going to take him to debug this. Probably not very long, but if I had to take a random stab in the dark and assume what might be going on here, that could be it.
And max corner, they should straddle 0, right? And they should be roughly the size. What is this entity that we're testing against? It's a wall, so it should basically straddle either side of 0, and it does, which is good. And the Z's in here, all right, well, so it looks like probably the problem that we're facing is just that we didn't actually give any height to our walls. So this is probably just a data definition problem because we didn't really add 3D to a lot of things. So when we add a wall, what we're going to have to do is actually add some depth to it. So if we go in here, we could say, all right, I don't know how high a wall is.
And there you go, I was right. I don't know if I was on mute for that just now, but basically I was just saying, right, that my hunch was that the walls had no depth to them, and that was true, right? I think we added depth for the stair, but that might have been it, and I'm in the wrong file here. Go to add stair. Yeah, we had that there. And then just up above here, yep, no depth to the wall. So I should have jumped in there and then just tried throwing that in and seeing if it worked, and then that would have been neat to prove myself right, but I did not have that foresight.
Let's say that it's half the tile depth in meters or something like this. We'll have to think about that a little bit. There'll probably be walls of differing heights, I'm guessing, in the game when we're actually done with it, because there'll probably be walls that are low enough for flying things to fly over, and walls that are tall enough to block flying things, or stuff of this nature. And so for now, we kind of gotta leave it at that. So anyway, we got to add that there, and then I suppose other things should also have a size as well. Probably the player should have a size. He currently does not appear to have a size, which is also odd, and the Monstars don't have a size, so most people don't have a size. Not sure what to really do about that. I guess we'll just give them some size for now. And I guess, so we've got a Y and an X. Yeah, I don't know. This is a little bit odd. 1.4F is probably what his height should be. I wonder if we should go through and actually think about these a little bit. Maybe that's something that should be on our to-do list. Feels like something that probably should be. So maybe go through and define how tall everything should be. And then, just have some opinion.
Gotta add that to do here, but I want to make sure I'm filling this incorrectly. So we're just going to set the whole dim. And it looks like we're just setting the Z on the player and the monster. And I would guess the familiar as well to all be 1. So we'll just do that for each of those. And then up at the top here, we can add that to do. Go through and define how tall everything should be. Because in the case of that floating head, familiar, it should be, well, like 50% of the hero's height, because it's like half of the hero's entire body is just that big old head he's got. But anyway.
About this, because at the moment we really don't know how tall things should be, and it's a little bit wonky. All right, and also for things that are flying, like the familiar, we should probably do a little bit of work on that. Make sure flying things can go over low walls, and so that'll be some good stuff to work out. All right, so we'll have to restart here because of course we changed the data definition, and so we'd have to, the init code is where all that stuff was set. So let's see. We should find that we stop now, and we do. We do seem to stop correctly. Although it seems like, are we stopping? Yeah, no, we're stopping correctly on the bottom stuff, which means I should not be able to go through the exit here because we're on the bottom right now. And now let's walk up to the top. We can walk up to the top, and we cannot walk through the top ring, but we should be able to go through. We can. So that looks like that's working properly now. So that's good. And yeah, that seems about right. Yeah, and I can't walk through the familiar, which is good. I can't walk through the Monstar, that's also good. I'm not sure what's happening with this, but that's looking good too. So our collision detection is working stably enough at the moment for the 3D stuff. Well, that's oddly jerky. I'm not sure why that's being odd like that. Is that, yeah. One thing that I did notice, you'll have to forgive me for a second here. I meant to check this out, but I totally forgot to. I meant to look to see when we did create window EX. Okay. I was noticing, I was programming some stuff earlier, like last week actually, and I noticed that if you...
What the hell? It looks like we're colliding with something here at the corner, but I can't make sense of what it would be. Almost like it's the bottom of the tree on the next level or something. I really don't know. That's really weird. I don't think that should be happening. And it only happens in that far right corner for some reason. Oh, wow. Okay. Yeah, it's only a problem if I go to like the very bottom. What if I'm at the top here? Does it again? Huh. Does it do that in the starting room? It does not. Well, that is funky. It's like we're catching an invisible entity or something. Or the collision detection just isn't working on the corner. I come all the way over here, maybe. Yeah, no. It is just in that one little spot for some reason. Probably not worth worrying too much about right now.
Past WEX layered to a window, your frame rate gets really, really bad. At least in OpenGL. I don't know if it happens with a div section like we're using here. So I just wanted to make sure that we weren't still passing that. It was just a quick thing that I had thought of, and I wanted to remember that not to do if we were doing it, but we aren't. It's not something I knew about, but it kind of makes sense, I guess, because if it's a layered window, it's got to go through the compositor first to do the layering stuff, and maybe it can't flip as fast. I don't know. But anyway, all right. So that's that means our collision detection is good enough right now in Z, so we can kind of say that this is done for now, and then we can also go ahead and say let's take a look at the other two that we added here, I think, because that seems like that seems like something maybe we should go through and think about a little bit. And in fact, it kind of sets us up for doing the ground stuff as well, because in order to do the ground stuff properly, we should have an idea of how everything lines up in 3D and how things are stacked on top of each other, how that concept kind of works, where tile chunks are in terms of how things are staggered, and all sorts of stuff like that. We probably want to get a handle on that. So yeah. So let's take a look and see what all this stuff hammers out to. So if I remember correctly, we set up a thing in here that said how big tiles were, sort of height-wise. It's let's see, tile side in meters and tile depth in meters, this sort of thing. And what we said is that the tile side in meters is essentially what the depth, I guess I should say, of a tile. So if we imagine a tile as a thing, sort of a unit that we think about typically as being this sort of element of space, we don't actually require things to be tiled at all, but it's sort of something we had been thinking about in terms of a unit of space. For example, if we were going to do walls that you stamp out, we'd probably do them in this proportion. So if we did something like this, what we're saying is that we've got a certain tile side in meters here, right? Whatever that is, whatever the world is initialized to. We're setting up the tile side in meters such that it's a cube, right? We're saying that these are all exactly the same. Like this, and this are all congruent. They're all the same length. And what's kind of weird about that is I don't think we actually care about height the same way that we do about sort of the two, or I guess we should say depth, as we do about the other two dimensions. Because if you think about it, when we're looking at the world top down, we typically want fairly fine gradations this way, right? In terms of entities. We know that entities are moving around, we typically want pretty fine gradations there. But in terms of height, I don't know that we really do. Typically, we'll probably represent very tall things, just sort of standing in a particular cell, and we don't really need the ability to have lots of things stacked on top of each other very often. That's not the common case for a game like this. It doesn't really happen hardly at all. And really, I don't know, it seems like we probably want to say that however high, a floor would be of a building, that's really the size of the cell that we care about. So, probably it's something that looks more like this, where you've got kind of something that's very sort of tall compared to its footprint. That's actually the cell, and maybe that's a good 3 or 4 times however big that tile dimension would be, right? So if that's the tile dimension there. So that's kind of what I'm thinking. If you look at how high a building normally would be, a building floor might be like 10 feet high, let's say, right? How tall is a typical building story? And let's see what this is. Calculating the height of a building. No, we just want to know how tall is a story, although 10 feet is a common estimate. So yeah, let's say 10 feet was a common estimate. What is 10 feet in meters? Well, it's 3.04, so close to 3. So we could say that 3 meters high would be probably a pretty good, a pretty good estimate for how big we might want our cells to be in terms of how we chunk up the world, right? And so when we build this, I'm thinking that basically what we want to do is for tile chunks, we want to kind of do the opposite of what we did here in some sense, right? For a tile chunk, we're often only looking at one slice of the world. Well, the thing I was about to say is probably wrong. So I'm gonna stop there for a second. Let's think about this. So we have one more thing to think about. So if we're thinking about a typical element as something like this, when we start thinking about tile chunks, I think maybe what I was gonna say doesn't really apply. But let's talk it through for a second. So,
Rectum of Justice asked, do you have a stream schedule for when I've gone through the VODs? Mondays, Wednesdays, and Fridays right now are kind of the loose schedule. Unfortunately, I don't have a set time of day, but I try to do it somewhere between 2 p.m. and 5 p.m. Eastern time is when I try to start them. And so that's, what is that? 11 a.m. and 2 p.m. Pacific. So, but it just depends on my work schedule and family matters. Those things all impact exactly when I can start, and so I'm not quite able to commit to a specific time because something will come up last minute, and I won't be able to stick to like noon or 2 or whatever it is, right? So around midday, Mondays, Wednesdays, and Fridays. I was doing it every weekday for the first 10 or so weeks. I actually don't know how many weeks it's been now. This might be the 10th week actually. So maybe for the first 8 weeks I did Mondays through Fridays. But I just wanted to carve out some other time for some other things that I'm working on in my spare time right now. So yeah, until further notice, that's the plan. And then I may change that up again in future. I'm just really trying to feel my way through it and see what level of commitment I want to give to this project specifically, because it's a very long-term thing. And if I I don't want to force myself to do it, is what it comes down to. I want the curiosity to always be the thing that's driving, forward progress. And if my curiosity starts to wane on it because I'm going too hard, then that's no good. I don't want it to just, be dead in the water because I burnt myself out on it. But that's not what's happening right now. It's just I've got these other things that are wow, they're really because I started. Here's what's happened. Because I started this channel and this project specifically, it's pulled me in some other directions that I didn't expect, and so now I really want to explore those curiosities. So thanks for doing these, by the way. Yeah, no problem. And feel free to reach out, async via DMs or whatever if you have specific questions that come up over the course of you watching either this or Casey's thing, because if you're just watching like an hour of this each day, you could easily get ahead of me and get into some material that I haven't even reached yet. You know, it's a very dense series, and what I've heard Casey say is basically that if you're getting gold out of Handmade Hero, it's because you're mining it yourself, which I like that expression, because that's basically what I'm doing here on stream each day, right? Like I'm sitting with him and coding along with him, and when I get something really valuable, it's after a lot of like plugging away on stuff that might seem very monotonous on the surface, and sometimes, especially when I get stuck on something silly, like a typo or passing in parameters in the wrong order, like I did the other day, that feels bad, and it feels like it's not the kind of struggle that I want to be going through on stream. And so that's why I've had some reconsiderations about the format of the stream, but I still don't know what to do about that yet, right? So just gonna keep pedaling along here, and again, see where the curiosity leads me.
What a tile chunk is an aggregate, basically, and we don't call them tile chunks anymore, I guess we call them world chunks. It's basically a region of space where stuff lives, right? It's sort of a storage unit for stuff in the world, for entities in the world. And so if we're thinking about how big that should be, what we were saying before is, you know, maybe if this was what our common sort of construction element looked like, I think what we were saying is like maybe 16 by 16 across, right, was the thing? Yeah. So whatever that unit is of construction that we tend to think in, even though, again, we're not explicitly representing this anywhere, it's just kind of a size guide at this point, because we allow entities to be any shape and positioned anywhere. So we don't have, it's not like a tile map where it's locked to it. If we're saying that we're going to be 16 across, right, and 16 this way, the question is, how tall should this chunk be in terms of units, right? So we're basically saying that this is, you know, something like this, right? This is, if this was our sort of construction grid, right? Wow, I did a bad job. This is not even square, the construction grid I drew, but you get the idea. Our construction grid basically says we store in chunks of this size in terms of construction elements. And again, things can be placed wherever you want in here, but this is sort of, you know, if you think of a typical wall piece that might be made by an artist that should be about that big or something, you know, blah, 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 we're thinking about it in terms of stuff that would go like this in the world, right? So the question is, if that's what we're doing for how we're storing the world, 16 by 16, which seems pretty reasonable, but we haven't really thought too hard about it. How high should it be, right? And so if we're saying that, you know, there's 3 meters, so this is a distance of 3 meters here, right? If we're saying that there's 3 meters per floor, one question is, for tile chunks, how many floors do we want to store? And it seems to me like probably the answer. All right, so I'm going to go back to the thing I was originally going to say. Thinking it through a little bit, I'll say probably what I was going to say is okay. Anyway, but how many floors do we want to include in a chunk? And I think that probably we only really want to include 1 floor, right? Because typically speaking, there's not going to be a lot of visibility floor to floor. Like typically floors are going to be opaque. And when they're not opaque, they'll probably only show through to one thing below it or whatever, right? And so what I'm thinking is, in general, we probably don't want to be pulling in lots of entities that are not involved in the computation. We probably want to just pull in the floor that's active, and then if you can see down to the floor below it, we'll pull that in as well or something like that, right? But in general, we won't be pulling in lots of floors like that. And if it turns out that we don't ever allow this case, like we don't actually allow things that show through to the bottom, then we could restrict it just to the 1 floor. But I think we probably do, for visual interest, we'll probably want to do that once in a while. And so for looking down, what we'll have to do is basically do a query where we say, all right, let's look at everything that's inside the current camera bounds that we want to use, and then we'll expand that by when we detect that we have entities that would allow us to see through to the ground. We'll sort of detect that and add layers going downward. So we'll drill down or something like that, right? That's kind of the way that I'm thinking we'll probably want to do it. That way we've got some occlusion in there and we won't grab more layers than we need. And so what I think is we probably want to just leave it to 1 layer at a time in those tile chunks, so that we don't have a situation where we are constantly, excuse me, constantly pulling in all sorts of entities that we really just didn't need to simulate at a high frequency because they're not even visible at all, right? So that's what I think we should probably do for now. Now, in order to do that, what I want to do is say, okay, we'll leave all the same tiles per chunk stuff the way we were doing it before, and then instead of making this tile side in meters, we'll just pass in another thing here, which will be the tile depth in meters. Tile depth in meters. And you can see that I've already sort of done it this way. This is already sort of what I guess, for lack of a better term, what I was expecting when we first typed in this code. You'll notice that I had already just set it to 1 tile high instead of setting it to 16 tiles high when we were doing this before. But what we're saying now is we're going to do higher than that because really the tile side in meters is a lot smaller than what we expect the average floor depth to be. So we're going to set it to that, and then we'll store it in here as well. And so then when we call initialize world in here, when we actually, initialize world, we'll pass that tile side, and then we'll also pass whatever we want the depth to be, right? Which is going to be 3.0 for now, and that'll be that distance. Now, when we go to grab a floor, now we kind of have this thing where we got two competing things that sort of fight against each other a little bit, and I'm not sure how we want to handle it. Again, if you take a look at the side view, so let's do a side view here. If you take a look at the side view of what happens when we have a multi-story thing like this, right? Let's go ahead and do that. So let's say here's story 0 of our building in 1, 2, and 3, right? And you know, we've got a stairwell that kind of comes up in here, something like this, and you know, maybe we've got holes in here and a wall or something, you know, whatever, you know. So what we have to consider is, previously what I was saying is to avoid numerical nastiness where we kind of have things that are standing on the floor that might drop a little bit below the floor, or things like, you know, who knows. I was worried about that, and I was saying, well, we probably want to make it so that tiles are like straddling like this, that world chunks are straddling so that they capture everything that's near the floor boundary. But the thing that's nasty about that is that would bring in, right, in a tile chunk, you would easily potentially say that like things like this that were overlapping this might go into this chunk instead of going into this chunk, right? Depending on where this was placed. A floating thing that was floating up here should clearly be in actually this tile chunk down here related to this floor, but instead it's going to be placed in this chunk. And our gather would find that, because our gather is going to gather everything, you know, in a region that looks like that. But what that means is we're always gathering two tile chunks, even if we could only see one floor, right? Even if this is all we could see. Here's my little, that's my little eyeball. It's pretty great, huh? If this is all we could see is just this floor, you know, we can't see any of the rest of this. We're still pulling in all of these entities. We might still be pulling in entities up here, and that's just not a good idea. So it does seem like maybe, even though it's a, you know, kind of a nice thing to do it this way, it does seem that maybe we want to do is do a nice inclusion thing where we actually do, and this would be our max thing that would come into play here, where we actually do something where we say, okay, let's actually make it so that a tile chunk actually just encompasses the floor itself, and it doesn't extend below or above the floor boundary. Now maybe we can stagger it a little bit. You know, maybe we can say that it's like a little bit like this, so you know, it has a little bit of give to it, so things are staggered a tiny bit. But on the whole, you know, maybe let's actually keep it fairly well aligned in that sense. And so if we want to do that, I guess let's see here. When we actually do our recanonicalized coordinates here, I'm not sure exactly what we're doing already in terms of how we recanonicalize them. Let's take a look. Actually, I guess it's not recanonicalized. It's chunk position from tile position, where we're actually placing these guys. And so offsets, let's see what we're doing. We're saying the world tile side in meters times the abs tile in any direction. So this is kind of a little bit wrong now, because again, tile side in meters is not how deep things are going to be. And so we really don't actually want that to be the case for these guys. What we actually want to do here is take just the x and y and multiply it by it. But you know what I could do? We could just say this is the you know, tile dimension or something like this, where we go ahead and say, okay, it's the tile side in meters, and then it's the tile depth in meters. And then this is just a Hadamard product, right? A Hadamard product of our tile dimension times that abs tile XYZ. That'll give us what we actually wanted for the position, right?
Okay. Just pause real quick so I can do that. So we have our tile dim, which is just going to be a V3 of the tile side in meters twice, followed by the depth for the Z-axis. And then I just split that up so it doesn't look so funky. And then we take Hadamard of the tile dim along with all of that. And that gives us our offset. I kind of want to make this its own thing. Call this like the chunk point or something, you know? That seems good. Just so it's a little bit clearer exactly what it is we're doing here to get that offset.
And that should work good. But now we got to say, all right, so how are these things being sort of placed? And it may be that we're already placing them in the way that I just said that we should. It looks to me like nobody here is doing an offset, which means, correct me if I'm wrong, but that would seem to suggest that we're actually already doing exactly what I just said, right? In other words, we don't have to do any work. That was just what was happening already, and it's only if we wanted to do the staggered version that we would have had to actually do something about it. Because if we set the abs tile z to 0, then obviously we would end up with 0. If we set it to 1, we would end up with it being 1 more over it. So really, if anything, I would say that all we really have to do here is we'd want to do an offset we'd want to do an offset for the x and y. We'd probably want the x and y to be half a tile over. So I'm trying to think of what the best thing to do is. I think probably what we'd want to do here is actually start drawing in a little bit how these things are layered. This would be a good thing to have debug info for. And so maybe what I'll do is I'll postpone this until when we actually have the debug code. We might say something like draw tile chunks so we can verify that things are aligned in the chunks we want them to be in, etc. Because that'll be a really, if we had some debug rendering stuff, it'd be really easy to verify what I just said. But since we don't, it's a little bit harder. So I'm just going to go ahead and double check that what.
Make sure that I get that whole to-do in there. And the chunks we want them to be in,
etc.
Okay. Yeah, and then we can go back here and see. I wonder if this will fix that weird bug that I found. For all I know, and it seems pretty likely to me. Whoa. Oh, never mind. That's fine. It seems pretty likely to me that Casey has the same bug. It's just, it's such an edge case that you wouldn't find. And we could go and try to debug it, but I suspect it's probably just we're hitting a wall there. But that could have been fixed just now, because you can see that I'm actually not having that problem anymore, it looks like. Let's see if I go back up. And then I try this corner. Yeah, so it could have just been like a depth thing, you know, and now that we've got our values a little bit more rigid there and well-defined, we're not going to hit it. Oh, well, there you go. I think I just saw it again. And there's no floor above me. So you know that it has nothing to do with... Oh, that's super weird. Now I'm stuck. Okay, I'm just stuck inside of the tree now. Stuck inside of the tree's hitbox. So yeah, there's something weird going on there in the corner of the room. Kind of makes me want to see if I can recreate that problem with my Zig code. So I might do that and then report back on Monday, because I just don't want to get too sidetracked on stream here. But it'd be interesting to see if that is just a bug that has always been there and, you know, I never saw it until now. But if it's also in the Zig code, it's probably safe to assume it's in Casey's code as well.
Because that'll be a really, if we had some debug rendering stuff. So I'm just going to go ahead and double check that what I just said is working properly. It is. Looks like that's fine. Now you can see that that floor is much higher up than it was before, which is because we changed the floor height to 3 meters, which is exactly what we would expect to happen. And let's see here, when we go upstairs, we also go up at a much faster rate because we've got to go all the way up to that top part there. So there we go, and that all works good. So that seems pretty consistent and reasonable, so that's fine. Okay, so let's leave that at that. So now what we have to do is start to say, all right, how tall should everything be, right? How big should everything be? And let's start to take a look at that. So let's go into handmade world.cpp here. I'm sorry, handmade.cpp, where we add our entity sizes. And let's just think about this a little bit. If we're going to add an entity, how big should it be? Well, a wall should probably be the tile depth in meters, right? It should be the full height of the floor, is what I would think. And since we don't do inclusion on the max, I feel like even though it goes all the way up to the top, we wouldn't even need to leave an epsilon. It would just work. Now, I'm not sure about that. Let's
hold on. Okay, so yeah, you got rid of this halving of the tile depth in meters. Yeah, I could see what he was talking about earlier, where it's just kind of weird if we want to think about the depth of a tile being the height in Z of an entire room. It just forces you to think about it constrains the way that you can think about tiles, I guess, rather than having them just stack and then having, say, the room height be a certain number of tiles high or something like that. Yeah, I don't know. It kind of constrains you into that room notion that he's choosing specifically because he's going for like this, you know, kind of room by room world exploration. But hard to say how much that matters.
I feel like even though it goes all the way up to the top, we wouldn't even need to leave an epsilon. It would just work. Now, I'm not sure about that. Let's see. So here I'm going to walk around to test that collision detection there. That all works fine. Go up to the...
Got a jet flying super low over the house, it sounds like. Thing is damn loud.
Top. Collision detection works there. And it works here. Yeah, so we can actually do it at the full height, and that's fine. So that's all good. No worries there. So that's nice. So let's take a look at what things...
See, he does like a very rudimentary, like, I'm just going to walk around the room, see if anything goes wrong. But I was like being very thorough and then checking along all the walls, and that bug doesn't show up in every room. It's in like 1 in every 10 rooms maybe. So it's just not something that you're going to find unless you're really going after it, trying to find bugs.
Should be other heights. Let's say that we've got the stairwell. Well, we already did that correctly because we said that that's going to be the depth in meters, which is that height. Now, you know what I'm thinking, though? If this were only the depth in meters, we shouldn't be colliding. So did we not use that as the inclusion rule? I'm guessing we didn't use that as the inclusion rule. I don't know if you see what I'm seeing there, but if the stairwell is only that big, then why are we able to walk down it? Maybe we can't walk down it. Let's find out. Let's take a look here. So when we do inclusion, when we were doing our inclusion testing, which is this stuff here, when we did rectangles intersect, what exactly does that call do, right? Let's take a look, handmade math.h. Let's take a look at rectangles intersect. So yeah, so you can see what's happening here, right? Basically, rectangles intersect, which is our call for doing intersection testing here, doesn't obey that max rule, which is kind of janky, right? That's not probably what we wanted it to do. That's just not, like, all of our testing is basically predicated on the fact that, you know, if I've got a rectangle and let's say, oops, here's my min corner, here's my max corner, right? All of it was predicated on the fact that that very last row or column, that very last infinitely thin edge is not included in the rectangle. And the reason that we're going with a rule like that is so that you can stack 2 rectangles perfectly together, right? Like, let's say I got a second rectangle here, like so, and you know definitively what the people at this coordinate are on. You know that they're on this guy, right? Not this guy. If the max were included, then there'd be no way to perfectly stack 2 rectangles next to each other without trying to figure out what the minimum floating point epsilon value was at that scale that you could use to put you 1 floating point unit over from the other guy, which would be a huge pain, and definitely not something we want to do. But for our rectangle intersection testing, we're not doing that, right? Our rectangle intersection testing says that you have to be less than in order to be considered intersecting. I'm sorry, in order to be considered not intersecting, which means that anything that was on, if the 2 rectangles abut in any way, then they are considered, you know, they're considered intersecting. Which
I wonder if that is causing that random bug, right? Like we might be just on the line where we're abutting with the top of the wall of the tree, right, in that one corner of the room. It's just weird that it's always in the corner, and it seems completely random when it happens. I mean, I guess that doesn't really not make sense either, but it's just hard to wrangle all of the potential variables that we have here that could be affecting why I'm seeing that bug in there.
I don't think we want to do. So even though that happens to help us in this particular case, because it means that when I walk up this thing, I can walk down it again, because I happen to be exactly on it, both at the bottom level and the top level, what I think that we would rather do is fix that by having stairwells hit regions extend above the floor a bit, which I think we want to do anyway, right? I think that's something that we would want to do anyway, but I don't know. So anyway, we could take a look at that, and that's something that we should play around with a little bit, just so we can kind of see what's going on there. Now that said, I don't actually know that's what's saving us. It could be that I'm not quite thinking about this right, because, you know, like what I'm also noticing is that if I walk into this guy, it stops me. And I feel like it shouldn't actually stop me, because I feel like our collision, that should not actually have been the case. Let me think about that a little bit. But if you know what I mean, right? It should be that if you try to walk into it, the thing that would have stopped it was this test wall call, right? Because we're not stopping you down here in the overlap testing. So it seems to me like we're actually still intersecting the stairwell even so. So that's actually not the thing that's stopping us, but it doesn't change the fact that it's wrong. And so first I want to fix that, and then we'll take a look and see what to do with the other part of it. So what we're doing here is we're basically doing an inversion test. So what we're doing is we're saying, let's test first to see whether they're not intersecting, and then we'll just return the opposite of that, right? So to test whether 2 things are not intersecting, what we want to do here is we're saying, okay, if the min of this thing, right, is less than the maximum of the other one. So let me draw out what this is actually doing. We talked about this before. In fact, I don't know. Can I actually find the drawing? Probably not. That's one thing we don't really have.
phone was so damn loud it scared the crap out of me. Wasn't ready for that. Muted it so that doesn't happen again.
Is how to search our drawings effectively. Because like, what do you do? How can you see where we may have drawn that? Who has any idea? Well, does anyone see it? I don't really see it on here.
You're on your own, killer.
Maybe overlap test, at least one point. Here we go. This was the drawing, right? So basically what we were saying before is, we have A min-max and we have B min-max. And so what we're doing is we're checking for things like, okay, if the minimum of B is greater than the maximum of A, then we know that they can't be overlapping, right? Because there's space in between where this one ends and where this one begins. So what we want to say is, let's suppose the max and the minimum were exactly equivalent, right? So B's minimum was right on the maximum, right? In that case, we would not consider them intersecting. So what we actually want to do is we want to change these tests here, for example. So when we do min versus max, like the one I just said, so if B's min is greater than A's max, what we want to do is set that actually to be if it's greater than or equal to, right? Because if it's greater than or equal to, we want to consider them not intersecting because that max is not included, right? And so that's true of all of those dimensions. And so now the question is, what about the other side of that? What about where we're testing the max against the min? And so what we're saying here in this case is we're looking for if B's max was over here, right? And so what about the case where they're exactly coincident? Again, we don't want that to be the case. We don't want to include that max-min overlap. So I believe what we want to do here is, again, say the same thing. We want to say that B's max, if it's less than or equal to A's min, right, that it's not going to trigger the intersection. So that seems to me to be more in keeping with the rule that we've set up and avoid this from getting into a situation where we have different tests returning different things. Now, we still are working properly in terms of going up and down, which again, I think is a little odd. So I'm just wondering what I'm forgetting, because in theory now, if we were right on the top, when we go here, we shouldn't actually, we shouldn't be actually going through like that. That's not correct. So my question is, what's actually happening there? And I don't know. So let's try and figure out what is actually happening there. So first off, let's make sure.
I'm just really curious to see if I can see that bug go away based on any of these changes, because I think some of the problems that Casey is elaborating on here are related to exactly the bug we're seeing. It's just a weird case where sometimes that corner tree, our collision detection thinks that we're hitting it, even though like we're clearly getting, it looks like we're getting stuck on nothing. Oh, there you go. So it happened again, and it wasn't in the corner. It was just randomly. And I can only assume that this is because we're hitting the top of the tree somehow when we come at it from the side, as I'm grinding along the wall here. And it's only in one direction too. You see, if I come from the left here, or the right rather, I don't do it. I don't trigger it, but approaching from the left I do. And so I bet if I printed it out, it would say that we're colliding with this particular tree right here. Oh, shoot. Well, that's very wrong. I can actually wander through the tree. Hold on. Okay, so, yeah, that's really messed up. Oh, is it? So, oh, wait a minute. Never mind. I got confused a little bit just then. Okay, let's try this again. Will we be able to do the same thing here? Nope. There we go. So now can I wander down through? Oh, it's so weird. Maybe I got confused and I was looking at the wrong thing, but I don't think so. It looked like I was able to just walk through the tree like it wasn't there. Yeah, I don't know. Weird stuff happening now.
We know how big this thing actually is. So if I go in here and I take a look at the stairwell, where are we placing it, right? So here's the first thing that I guess is affecting it, right? Is we're actually placing these at an offset in the world, right? And oh, well, you know what? That explains it right there. These placements are placing us, so basically what our dimensions are interpreted as being around where we are, right? So basically when we say what the dimension is, I guess I got to zoom back to where we were. No.
I want to back up and see if he got rid of that. Yeah, chunk. Oh, I'm looking at the wrong thing. Add stair. Yeah, this thing right here. Does he get rid of that? Or is he going to add it in for the wall?
So basically, what our dimensions are interpreted as being around where we are, right? So basically, when we say what the dimension is, I guess I got to zoom back to where we were. Nope. Let's see here. Day 76. Where is day 76? There it is. This is such a funny drawing at this point. All right, so here's day 76 again. There we go. Am I the right size? It's hard. That's the other thing that I don't know how to get this to do, is to zoom to a known size. I really wish Mischief could just do that. I don't know, maybe it can, and I don't know how to do it, but yeah, it would be nice. So does this look about right? I think that looks about right. I think that's how big things were. So let's just say that that's how big they were and keep going. So I guess what's happening here is just that our entities are actually this size, right? Our entities, not size, are actually placed like so. If this is the ground, right, then essentially our entities are doing that. And so that explains why they can go and they're considered intersecting these stairwells that are, even if the stairwell is only set up to be that way. So what we want to actually do is place entities such that their, a base and their dimension kind of goes up from the base like that. So I wonder, I'm just thinking how we want to do this. I wonder if that implies that our rule for where entities are should actually be that the position, you go out from the position, but you go up in Z. I don't know. You know what I'm saying? Like in terms of how you align the bounding box of the entity, I wonder if we want to make it so that your alignment is, from for the standpoint of a three-dimensional drawing here, right? I wonder if we want to make it so that essentially the point is in the exact middle of the bottom face of your bounds. And so
I don't think this has anything to do with the problem that I am seeing. What he's talking about right now, where we've got the origin, in XY being whatever it is, and then the Z is shooting out in either direction, when maybe we would just want to go straight up from there. Why would that affect the way we're catching random trees in random places? It shouldn't. And all the trees should all have the same dimension. All the walls should. So I don't understand why that's happening. Santos, how many boards would a Mongol horde if the Mongol hordes got bored? Is there like a Mulan joke in here somewhere? Something Eddie Murphy.
The height is measured that way, whereas the other dimensions are not. The other dimensions are measured, as being equally spread out from where you are.
That's far too forward thinking for you. Well, either way, I don't know the answer, so.
I mean, the other thing we could do is that everything is a minimum corner. So you're always specifying your minimum corner, and then everything is out from there. I don't know. I don't know how I feel about that. So let's take a look at where it's actually used, for starters. That'll give us a little bit of an understanding of it, I suppose. So if we were to go into sim region and take a look at basically the places where I actually do something with it. So here's an example right here. And then we've got another example. Let's see. So we do a fair bit of stuff that wants to be symmetric, like entities overlapping rectangles and sizing them. So it really looks like we want to just keep treating it that way. So it seems like what we want to do is we want to do that placement where we're going to place things so that they're adjusted properly. Yeah, I feel like it's just the center plus the dimension is just a better thing to do there. Yeah. So, I mean, that's what it is. That's what it is. So I guess what we want to do here is say, all right, let's go ahead and just account for that. Maybe what I'll do is make a call in addition to add low entity, something that takes a dimension. I'm not sure. Let's take a look here. Add low entity. Everything has one. So maybe I'll just add that to the call, and it will automatically maybe do that adjustment for you, let's say. Yeah. So I guess what I'm going to do here, and I guess we should give the sword a dimension in Z as well. Maybe just a very small dimension in Z. I guess what we should probably do here is say, all right, let's add a new function, and there's going to be a function here that basically does the same thing as add low entity, but it's going to be let's say a grounded entity, right? And a grounded entity is going to have a dimension and a position, and we'll say that when you pass in whatever that position is, we're going to offset it we're going to go ahead and offset that position by whatever the dimension is. So when you pass that dim in, you won't have to set that anymore. It'll kind of do that for you. And so what this will do is it'll call add low entity with the position and the type that you specified, and then it'll go ahead and set the dimension for you as well. But it'll also do, before it does that, it'll do that that mapping for you, where essentially it offsets wherever the entity was. So if I take a look at handmade world.h, oops, there should be that offset for call. Where is that offset? Map into chunk space. So this, right? So if I do that map into chunk space, world position, offset p, and so what we'll do is we'll say we're going to map into chunk space the original p that we got, and then we'll take the dimension. We'll say that we're gonna offset it by half the dimension in z downward. So to sort of I'm sorry, upward, right? So that we'll move it up to account for that, so that it will be based on the ground properly, but that its actual placement in the world will leave its bottom, the bottom of its bounding box on the ground. All right, so we'll go ahead and return that, and that looks good. So we've got now some work to do here, where I'll basically say the dimension is going to be let's see, something like this.
Okay, so he's really committing to this change here, so I'll just get caught up. Hopefully he doesn't just walk it all back. You never know. So we add the low entity, or I should say add low entity call, where we pass in all of this business. And then we say that our entity's dimension is equal to dim, but dim hasn't changed. Maybe he's just gonna say dim plus offset p. This is kind of funky because he's multiplying. Well, what is this? What all does this take? It also takes the game world. Because we're multiplying the dim by half, but we don't have this is, that's the z coordinate of another vector 3 that this procedure takes. So I'm guessing he wants that to be the z property. I can only assume. That is just spelled wrong. And now, what is your problem? Mismatched types. What is this even? It's a world position. Oh, I see. He passes in. Okay. So that's where the offset p gets used. I thought it wasn't being used here. And then we set the dim. Interesting. Okay, and then down in add wall, we are going to set the dim to be passed into add grounded entity now. And it's just going to be all of that, if I am not mistaken. And then at the end of all of that, well, maybe we don't actually need to do that since it's going to be set in here, right? Yeah. So we just don't need to set the dim inside of adding each individual thing anymore. And then we can just do this assignment here and dang it. Hopefully be good to go. Oh crap. This is just going to be all tile sided meters. Okay. And then the Z is the tile depth of meters, and this looks okay. I think this is what we're going for.
And this. So there's a wall. And then I can say add grounded entity dim and delete that, right? Does that make sense? None of the overloads. Oh, of course you would make me do this. Thank you, C. Oh, right. Maybe it wasn't as bad as I thought. let me give it another chance. Okay, no. C was not being mean to me there. It was just me forgetting to select the Z coordinate. All right, so, and I guess I have to pass the world there too, probably, right? To this guy, so, oops. So it knows how to do that mapping. So that should allow us now to place things. Let's double check that actually worked at all. That should allow us to place things properly in Z, and we'll see if it actually did. And of course, our guy is now lower than the walls, right? So he's like down a bit in Z, and so now that.
Uh-oh. What did I break? That's great. Very helpful error, you know. What has happened? What did I do? We didn't change much at all. And what we did change shouldn't be just causing it to explode. Map into chunk space. Like, are we hitting an assert and it's just not telling us what assert we're hitting? It wouldn't be the first time. That's in the world there. We do the add low entity. Yeah, there's just nothing. Oh, is it because? Oh. I think it's because, yeah, this should just be the result. Yeah, I think that's all that was. Please let that be the case. Yeah, okay. So now we can see the same thing that Casey was seeing. We're getting kind of lodged into the trees here. Yeah, and then we've got like an invisible wall here. It's just the collision detection is detecting the entities in a different place now. Although we also can't even go through the walls now, so that's kind of weird. But I think we've got the same problem as he does, so I'm not too bothered by it.
Should stop happening once we actually place him properly as well. So let's go ahead. We've got add wall, we've got our add stair. So if we want our dimension again, let's go ahead and set that up. So we've got, there's the X, we've got our Y here. Pass that in there, and our Z. So pass that in there, and that will automatically do its thing. So add grounded entity. Oops, entity. There we go. So now what we would do is we would just get rid of this, so we don't actually need that offset anymore because it should just offset itself. There we go. And what else we got? We got our S word. Our S word isn't a problem because it doesn't actually have a position at the moment, so we can leave that B for now.
Need to get caught up here real quick. Okay, so we set the dim there. And then this, let's see. Still stuck on the stair there. Chunk position from tile position. We pass in. Oh. That's for the stair. So did he just get rid of that altogether right there? That's what I'm seeing. I see. So the offset, yeah, I think this is just going to go away. But I don't know if he actually changed that. Yeah. I don't know if he's actually going to change the procedure or not. But we'll just leave it alone for now. Okay, add grounded with that dim. And then we set the flags. And I think that all looks fine.
There we go. And what else we got? We got our S word.
Yeah, the sword. Add sword.
Our S word isn't a problem because it doesn't actually have a position at the moment, so we can leave that B for now. Our player, he should be grounded, so let's take his dimension here and actually set him up properly. And he should be about 1.4 meters high, right? That was what we said the height of the hero should be, I think. No, that can't be right. He's not 1.4 meters. He's a little kid. We did this before, but I forget what it was. How tall is, let's say, a velociraptor? How is that the most common? What is going on here? All right, well, whatever. How tall is, I don't know, maybe he's, let's say, I don't know how old he is. Let's say 7-year-old. 63 centimeters, right? So 0.63 meters. Does that make sense? Right? You know what I'm saying? 0.63 meters is how big our kid will be. There we go. Seems reasonable. And that's just how tall he is. So if I go ahead and move these out, we've got he's 1 by 0.5 by 0.63f. Delete that, and we'll add him as grounded, and we will add his dimension there. And that looks about it. Oh, we're almost out of time. So let me just finish this guy up for the Monstar. The Monstar is 1.0, 0.5, 0.5 at the minute. I don't know why our Monstar is so much taller than our guy, but I guess that's just because monsters are bigger and scarier. So we'll add grounded entity there. Dimension, and again, dim equals 0.5, 1. Oops, nope, 1.0f, 0.5f, 0.5f. Oh, that's good. .x. Well, good that we caught that accidentally. There's the familiar, and we'll have to do some more work on the familiar later because we actually want the familiar.
What did he see? He saw a little bug in there. Oh yeah, he didn't set the Z on the familiar. Okay, so that's straightforward enough, and then we just have to work on the familiar. Another nice thing about Odin that we can just assign all that stuff straight up. Although I don't know why he couldn't actually before. Not sure why he didn't. Maybe it was like a holdover from before we had vector 3s. I don't know. And then this becomes that. And now I think we are all set.
F, 0.5f, 0.5f. Oh, that's good. .x. Well, good that we caught that accidentally. There's the familiar, and we'll have to do some more work on the familiar later because we actually want the familiar to float, and we haven't done anything about that yet. So, grounded entity, there we go. So, what's the problem here? No semicolon. Nobody likes a missing semicolon. So let's go ahead and run that and see where we're at. Let's see if we can actually stop our guy. That looks a bit wrong to me. It looks like we're still lower than the trees are, which isn't my intention. So I've got a little bit of bogusness happening in my code. More importantly, we're still getting that, so that's a little bit odd as well. So something's a little odd. Let's just take a couple more seconds to take a look at that. Where is
the offset thing did kind of seem weird to me if we go in here, because having the Z of the dim still doesn't start us at like 0 and only go up. That just means that we're going out from the origin in the XY plane evenly in either direction by half. Which, to be fair, I don't know if that was actually the decision he made to go that other way, but I thought that was what we were doing here, so I could just be lost. There's a really great chance that I am.
My add grounded entity code, there it is. So let's see, let me just make sure I did this reasonably. So map into chunk space, we're taking the initial P, and then we're doing that mapping, we're adding it at the offset P, so that seems right, we're saving the dimension. That looks roughly correct. Let me go ahead and step into that, but otherwise I guess we'll have to leave it for tomorrow, and we'll debug it tomorrow. Grounded entity. Let's see what it says here. So, map into chunk space. Oh, you know what though? Now that I think about it though, really our drawing code is slightly wrong. In fact, I should fix the drawing code first before I look at this. Our drawing code uses the Z placement to determine where to draw the guy, but it really should use the minimum of the Z bounds, right? It shouldn't be using this as the entity Z, right? Instead, it should be using, it should actually be using that point offset by, it should be using that base point, because we're drawing up from the base point. That's how we were actually doing all of the other rendering, right? Like when we draw the rectangles, we're actually doing, I assume we're actually doing that, but I don't actually know if that's true. How are we doing it? Let's see. Draw rectangle, player top is entity with height, 1.0, let's see here. Player left top, player left top. Where is player top? Okay, there it is. So player left top. Oh, we're not using that code at all. That code is just bogus. Entity ground point, entity Z. So when we do this computation, when do we actually offset the point? By entity Z, right there. So what we're doing is we're saying that the center is the offset. Yeah, you know what? This is going to take a little bit because this I think is just wrong. I think our drawing code is just bogus to begin with. So that is actually, it's not a fair test to say that it would look like it was in the wrong place because this code is just kind of bogus. So what we should probably do is fix this so that it's actually drawing it so that the Z is actually starting at the lowest point and going up from there, because that's actually how we're thinking about the drawing in terms of how far it should be offset. So that does seem a little bit bogus, which is how we're doing it. But either way, we've got some bugs to deal with. So I'll leave that for tomorrow. I'll put that on the top of the to-do list. So we already went through and went how tall things are. So let's say debug drawing of Z levels and inclusion of Z to make sure that there are no bugs, because there are some now. Okay. All right, so let's go ahead and go to the Q&A.
And there you have it. Another day of Odinmade Hero complete. I'm suspecting that the bug that I discovered earlier is still there. I'm going to go see, and I can't even really test it now because we've got this weirdness going on with the whole Z thing. So I will go see if that bug was there in day, whatever this is, or the day before, day 75 of my Zig code. And then if it's there, then don't have to sweat it. You know, it's obviously still a problem if Casey never finds it and solves it, but it's not my problem to fix, in the sense that I'm not. The problem is that if the bug is still hanging around and it's causing issues elsewhere, when we get further down the line and I start seeing issues that Casey doesn't have, it could further compound the problem, because then the bug is like infecting these other things that we're trying to do with the code. So that's it for me. I would stick around and do the Q&A, but I think I've just left it as an exercise for myself to do off stream. And then again, because sometimes he'll get a lot of the same questions over and over, about like, why are you doing this why aren't you using Unreal Engine? And those kinds of questions do come up periodically, or it'll be something he'll explain the same thing. He'll get asked the same thing pretty frequently. That is just not, no point in me restreaming that, but if anything interesting does come up that I want to talk about, I will talk about it on Monday. So have a good weekend. Thanks for hanging out with me, and I will see you in the next one.